A consensus algorithm is fundamental to ensuring a blockchain remains a trustworthy version of truth. It also prevents any potential adversaries from breaking the system. While this method of achieving consensus has been successful so far, it does have some issues. There are two commonly discussed issues with proof of work: high energy consumption and the miner monopoly problem. First, proof of work leads to an extremely high amount of energy consumption. Proof of work calculations require a lot of computing power. All this computing comes at a cost, both financially and to the environment. To mine Bitcoin, miners set up mining rigs, which are high-powered computers that process new blocks. A rig can be a dedicated computer designed and built specifically for mining. It could also be a computer that was built for something else, like a gaming system, but which has enough memory and processing power to perform the calculations needed for mining. People can set up mining rigs in their homes, but there are also mining farms run by larger operations housing hundreds and even sometimes thousands of rigs dedicated to Bitcoin mining. In 2017, one of the world's largest Bitcoin mines was located in Inner Mongolia, and it housed 25,000 machines working 24 hours a day to mine Bitcoin. All these mining rigs around the world demand a lot of processing power. Some reports claim that Bitcoin mining is consuming more electricity than 159 countries around the world, including Ireland and most countries in Africa. At the end of 2017, global Bitcoin mining consumption used as much energy as 2 million US homes combined. And it's actually possible to use a Bitcoin mining rig to heat your home. The second problem is the miner monopoly problem. Because Bitcoin mining requires a lot of computing power and energy, those who have the resources to access more equipment have an unfair advantage. The diagram here shows the distribution of the largest mining pools around the world. As you can see, it's a little bit skewed. The mining farms we mentioned earlier actually contribute to this problem. They've helped lead to a monopoly of Bitcoin miners that control a majority of the network. Since these nodes dedicate more resources to the network, they have more say in which blocks are considered valid. This causes the network to lean towards becoming centralized rather than staying distributed like it was originally intended. So that wraps up the issues with the proof of work algorithm. Given these challenges with proof of work, other consensus algorithms have been developed to try and fix some of these issues. Coming up, we'll explore some of these algorithms in more detail.